Hello friends. So here we're going to talk about solving a rational and then also a radical equations. So the first thing we have to think about is, what is a rational equation? Rational equations have variables in the denominator. So if you look at what we've got going on down here in the problem we're going to solve, you see that there are x's in the denominator. Okay? So we're going to solve a rational equation. The first thing we need to do, we have these steps. We can identify the LCD. Then we're going to multiply all terms by the LCD, the least common denominator, to clear the fractions. And then we'll solve the resulting equation. And then we have to remember to check, because you can't divide by 0. So we're going to end these problems. We might have some domain restrictions. Okay? So we'll run through this. We'll do a couple problems, and then we'll talk about radical equations. So the first thing we do is we need to determine what the LCD is. And the LCD is x minus 1, x plus 2. So in order to solve this problem, we're going to multiply both the left and the right side by x minus 1, x plus 2. And when I do that, what I end up with is something that looks like this. So I write the LCD on either side, and it looks like this. And what you see now is that there's a common factor we can cancel from both sides. On the left, the denominator goes away, x minus 1, and on the right, the denominator goes away, x plus 2. I'm really going to encourage you guys to actually write that out and cross them out instead of doing it in your head, to avoid making the error of crossing the wrong one out. So once I'm done with that, that leaves me with x plus 2 times 2 equals x minus 1 times 3. So I determined what the LCD was. I multiplied by the LCD to clear the fractions, and now I have a linear equation I can solve. So I'll distribute on both sides, 2x plus 4. On the right, I've got 3x minus 3, and then we'll go about just solving the equation as usual. So I'll add 3 to both sides of the equation. That gives me 2x plus 7 equals 3x, and then I'll subtract 2x from both sides. So I end up with x equals 7, or rather 7 equals 1x, and that's my answer. So, but as I said, remember, you always want to check, and the main thing we want to check for is that when I take this 7, when I go back to my original problem, is that it does not create 0 in the denominator. All right? Remember, you can't divide by 0. So if I wanted to come over and check down here, we would say 2 over 7 minus 1 equals 3 over 7 plus 2. And we end up with 2 over 6 equals 3 over 9. And because both of those fractions simplify to 1/3, this is a true statement, and we know our answer is correct. So let's just try one more of these. So again, here we have a rational problem that we need to solve. The LCD in this case is just x. We only have one thing that we're dealing with in the denominator, and it's just that x. So the LCD is x. And what happens when I take this and I multiply each of my terms by x, I've got x times x minus x times 12 over x equals x times 1. So I put an x in front of every term, and I ended with x squared. You'll notice that the x and the x times x divided by x, those cancel to 1, minus 12 equals x. So here we have x squared minus x minus 12 equals 0. So what I've done is I looked at this and I said, all right, well, I've got x squared. And in my mind, I know that x squared means something is quadratic, right? So quadratic equations, when we're solving those, we always want them to be in descending order equal to 0, right? So quadratic, standard form, ax squared plus bx plus c equals 0. So working through this problem, as soon as I noticed that x squared, I knew I was going to want something in that format. All right, so now that I've got my quadratic equation equal to 0, I can factor it. I would say most problems in this section, when you end up with something quadratic, should factor. In the real world, they don't always, but I would be looking for them to factor. And so now solving this quadratic equation, I end up with x equals 4 and x equals negative 3. So these are my two answers. And the one thing I want to make sure I do here is now check. I need to check and verify that these solutions are both true. So I want to check each, and we want to check them in the original equation. So 4 minus 12 over 4, which is 3, equals 1. And negative 3 minus 12 over negative 3 equals 1. And both of those work out. I've got 4 minus 3 equals 1, and negative 3 plus 4 equals 1. All right, so we can have two solutions. And sometimes we'll do these problems and one solution won't work and one solution will.